Hey guys, we're back here in TinkerCAD. This is our second session doing TinkerCAD. So the first one, we learned how to turn on a light using two batteries, and we also learned about resistors, and we also learned about the breadboard. Today what I want to do is also we want to learn about the Arduino board. So let's go ahead and get started. So I'm in my dashboard here. Let's click new, and let's create a new circuit design. Alright, and as this is loading up, if you look down at the bottom there where my face is, you'll see this little board here. This is our Barnabas noggin. So with this project, we're going to be using the Barnabas noggin, which is in your kit. The reason it's like this is that it fits directly behind your robot, and so we have it nicely designed and shape-wise fits perfectly. I want to point out that the pins here, we have pins on the top here and also on the bottom. These match the Arduino, okay? So if we look on our TinkerCAD, we have this Arduino. So I'm going to click here and drag it in. See, this is blue. It's rectangular, not this robot shape with feet. But the pins here, you see the black pins right here, black pins right here, and then also the black pins on here and the black pins on here, they match. All right, just so we don't get confused, we're gonna have a blue Arduino on here, but when we start doing it in real life, we're gonna be using the green noggin. All right, so what is up with this Arduino Uno thing? What is it? Well, I like to think of it as the robot's brain. So if we think back the four different parts of a robot, we have the body, we have the heart, we have the brain, and we have the personality. Okay, so this is the brain of our robot, and it's the place, as we remember, what is the brain? It's the place where information is stored, and it's also where decisions are made, which is why it's like a computer. A computer does those things. All right, so this is where our information is going to be stored and where decisions are made. The thing that we're going to be put the thing that we're going to put inside of it, or the information that's stored into it, is the personality or the code. The code. So we're actually going to do the code as well. So we'll get this play with that. All right, so we have the brain here. Now this is where it gets like a little bit confusing because I'm going to tell you that it also has a heart involved here. So it's a brain, but then what happens is that the heart or the power of the robot is actually going to go through the brain as well, which is going to power stuff. All right, so just kind of keep that in mind here. It's mainly a brain, but it's also going to get some power, so it's got a heart connected to it as well. All right, so we have our brain here. I'm going to just zoom in here. The first thing to do, let's just do a light. Okay, and I'm gonna go blue just because I want to. All right, and let's try to turn this thing on. So cathode is the minus that needs to connect to the minus of the brain. The minus of the brain is GND. So if I go here, and there's a bunch of GNDs here. There's one here. There's one here. Let's see. There's also one here. So we got 3 GNDs. Our noggin also has 3 or maybe 4 even. Alright, so let's go. I usually want to use black. Into the cathode. Cool. Alright, I have a wire there. And then let's use a red wire to connect the plus. So if you remember, I said that the brain also is going to have a battery connected to it, and so it has power. Now the plus is going to be the positive voltage, so that's 3.3 volts or 5 volts. So this brain has 2 power sources. It has 5 volts and 3.3 V. Now they both share GND, okay? So we have GND connected, that's fine. Now which power should we use? 3.3 is a little bit less power. And if you remember, these LEDs, I'm not sure if I mentioned it last time, but a lot of LEDs take 3 volts. So 3.3 is a little bit higher than 3 This light might explode. I'm not sure. Let's just try it out. It's just simulation, so that's the nice thing. Okay. So I put 3.3 V and G and D. Let's see. Let's do the simulation. I think the light might explode, but you know, you give it some thought. You figure out what you think. Okay, I'm gonna go, and it exploded. Okay, it said LED is it's taking up 206 milliamps right now, but the maximum is 20 milliamps. So too much current, exploded. So what do? We need to add a resistor, right? We learned this last time. Let's see if I can figure this out here. Still figuring this out here. Okay, I'm just gonna delete. Guess I need to work on my wiring adjustment skills. Let's use 470 ohm, and let's redo the wire here, okay? There. Alright, and if I do simulation, this time it turns on and it doesn't explode because we have the resistor here. Okay? Cool. Now, let's do the same thing, but using a breadboard. Search for breadboard. So the one that's going to be in your special kit there is going to be this one. Okay. Let's turn it. Cool. So let's put our LED. You remember how the breadboard works. Holes that are on the same row and also on the same side of the valley of death, they are connected. So all these are connected to each other, and all these are connected to each other, but this hole is not connected to this hole because it's separated by the valley of death. All right, so let's do that again, but with the light. So I'm going to take this, I'm going to turn it actually. I think I should just plug in right like that. Okay, cool. And the long leg is the anode, and that needs to go to the positive. All right, so that goes to the positive. So I'm going to use, let's use 3.3 V because that's what we used last time. But before I forget, we also need to put a resistor, right? We need to put a resistor between them because we saw that it exploded last time. Okay, and the resistor is kind of big. It stretches across 1, 2, 3, 4, 5 rows, so I need to move this down. Oh, there, I did it. There. Okay, because of how the rows work. So this connects to this, so that's good. And then this other side of the resistor connects to that because it's on that same row here. So we're good. And then the last one is we just need to do, let's do a black wire. G and D. And to this top row to connect to the cathode. Alright, so now we have it with the breadboard, and again the breadboard is useful because it allows us to actually connect these things in real life. Right? Otherwise you have to like hold all these wires with your fingers and it's just crazy. Alright, let's start the simulation. Blue light turns on. Very good. Okay, now I have a question. What do you think would happen? I'm going to stop the simulation if we use 5V instead of 3.3. So if we use 5V, we're going to be increasing in power, okay? But let's see. But we still have the resistor in there, so will it be okay? I think it's gonna still be okay because we have the resistor. But maybe it's so much power. Like that difference of 1.7 volts is so much power that this resistor is not enough, and the light will explode. I don't know. Let's see. Oh, okay. Still works. Still works fine. Now let's just play a little bit. You know, I just get these ideas. All right, so we have this resistor here. It's 470. What if we change it to 400 ohms? So it's a little bit weaker resistor. So it's gonna stop less current. It's gonna allow more current to go through. Maybe, is that still enough? It's still good. What if I made it like 200 ohms? Do you think it's still able to stop enough current? So now it's like a really weak resistor. Will it still protect the light? Still good. Okay. What about 50? Still good, but look, it's super bright, and look. It says the current through LED is 53.5 milliamps, but the maximum is 20. So it's saying that the LED can still work, but the lifetime will be reduced because you're basically like putting the max in there. So I have maybe a little exercise for you. Okay, so let's see if you can find the resistor that makes the current exactly 20 milliamps. Okay, so right now it's 53.5, right? So you could play around with the resistance here to see if you can get it to exactly be 20 milliamps. Okay, it's just let's say if I do 40, what happens? Just curious. Now it's 65, so it went up, right? So I'm going the wrong way. So that's just an example. So that's my first challenge, is go ahead and try to find the resistance so that you get exactly 20 milliamps. If you want a little bit more context, if you want to look it up, there's this thing called Ohm's law. Okay, let's see, this is from our previous video here. I'll write it here. I'll leave it to you to look it up if you would like. Ohm's law, which is V equals I times R. This can actually help you figure it out. This is like a formula that goes with this exercise, but you don't even have to go there. If you want to just experiment and not worry about Ohm's law, and just kind of like play with the numbers and try to get it to be exactly 20 milliamps, go for it. I think that's a great way to do it as well. This is only if you're interested. You can check out the Ohm's law and read about it and see how it might help in this process. All right, so now we have that. Let's talk about coding. So I'm going to change this back to 470 ohm. Okay. So far, I have it so that I'm going to stop the simulation. So far, I have it so that when I start the simulation, the light turns on. And the reason why is that once I start the simulation, 5 volts just goes to the resistor, goes through the light, and it turns on. Well, what if I want to make it so that sometimes it's on, sometimes it's off, like a switch? Well, what I need to do then, in order to do that, I need to connect this here, not to 5 volts. I need to connect it to one of these numbers here. You see it says 0, 1, 2, 3, all the way up to 13. Okay? These are like switches. I like to think of them like nerves. Okay, because you remember that the robot Arduino is like a brain, right? So let's say my brain is trying to move my finger right here. There's a nerve that goes from my brain all the way to my finger to make it move. So in the same way, these numbers here are like different nerves. So whatever you connect to the number, it will be controlled by that number. Okay, I'm not sure if I said that correctly, but I think you get the point, right? So let's say if I connect this instead of 5V, okay, And then I think it's easier for me just to delete it because I'm still working on that. And I'm going to use yellow because red is like it's always on, the kind of like power thing. I'm going to use yellow here. And I'm going to connect it to 7 here. Okay. So now what I did, I connected the plus, which is connected to the resistor. So the plus of the light, which is connected to the resistor, which is now connected to the yellow wire. I'm connecting the plus to the number 7 nerve. So now, if I start simulation, the light does not turn on. Why? Because I've started the simulation, but the number 7 nerve is not turning on the light because I didn't tell it to turn on the light. So how do I tell it? How do I tell number 7 nerve to move? Well, this is where the code comes in, the personality part, right? So let's go to click over here on code. And you have like blocks, so there's different types of way to code. For this class, we're gonna go text. So I'm gonna go here, go to text, just say continue. And then we're gonna have this stuff in here. Okay, it says void setup, but all this stuff, we're just gonna delete it just to start fresh. Okay, and I'm gonna move this over here so we can see everything. All right, so this is our first time that we're gonna be doing code. This is the personality that goes into the brain. We're gonna use our code to turn on nerve number 7. Okay. So the first thing we need to do is you need to say void. I'm gonna just zoom in here in case we can't really see here. Okay, void setup parenthesis curly brace curly brace. Okay, so let me just say what just happened here. So we're writing text code. I wrote void setup. Okay, so that seems easy. Something I want to point out, we have to, it's case sensitive, okay? So I can't do positive, or sorry, not positive, capital V there. It has to be all lowercase, okay? You can't have like a random capital E there or something like that, all right? So it's case sensitive. And then you have to make sure you get the right parenthesis, so that I have a open parenthesis here, it's the one facing to the right, and then a closed parenthesis here. Oh, that's not what I wanted to do. Backspace. A closed parenthesis here, and then this is open curly brace, and then closed curly brace. So the code that is going to run when you do setup is going to be in between this open curly brace and this closed curly brace. So we're going to put our code right here. All right. So this is one, we call it a function. A function is like a set of commands. So whenever your robot turns on, whenever your brain wakes up, it's going to first run the setup function. Okay, it's kind of like wake up. You could also call it wake up. The first thing you do when you wake up, you're going to do whatever is inside the setup function. So we're going to leave it blank for now. Then we're going to make a second function, void space loop. So you always start with void for now. That might change later, but for now you always start with void, use space, and then this function called loop, and you do your open and close parentheses, and then you do your curly braces. So that tells you what's supposed to, what commands are going to be inside loop. All right, so you have void setup and void loop. So void setup runs only when it wakes up, and it runs one time, and then it never runs again. Now loop runs right after setup goes. So when robot wakes up, setup turns on, and then right after that, it will do whatever is inside loop. Again, right now it's empty, but it's going to do all the commands inside loop, and then you might be able to think, it's kind of a hint, the name of the function is loop. So what happens after that? After the first time it runs loop, it just keeps running whatever is inside loop over and over and over again in a loop. And that's it. So let's do our setup. So when our brain first wakes up, we want to say, hey, I'm going to work on there's something connected to nerve number 7, so make sure that you set up nerve number 7, like wake up nerve number 7. The way you do that is pin mode. Okay, notice here, lowercase p but capital M, very important. Pin mode 7, comma, output, all caps. All right, so this kind of tells the brain to wake up and say, hey, I'm going to use nerve number 7. Make sure you wake it up because we're going to be using it. Okay, and then we're going to say semicolon there to end our sentence. It's kind of like this is C++ code. The end of a sentence is kind of like a period. In English, right? We put a period at the end. In C++, we use a semicolon. All right. Okay. And then I'm just getting rid of the extra lines there. Okay. So I got rid of, but if you left the extra lines in there, it would still work. I just like to kind of keep it neat there, and I would say try keeping it neat as well. Okay. Then we have that. Then in our loop, we want to say, well, what do you want to do? So after I do a setup wake up stuff, what do I want to do in the loop? Well, let's just turn it on. Let's turn the nerve on. So digital write, and take a look. Lowercase d, capital W. I have open parentheses 7 again. I'm going to talk to nerve number 7, comma, high. Close parenthesis, semicolon. Get rid of my extra spaces or extra lines. Cool. Let's zoom out here. Cool. All right. So now if I run my simulation, it turns on. So high, it turns it on. Now let's say if I want to turn it off, it's just the opposite of high. Oh, I can't edit this until I press stop here. I'll say low. Start simulation, and this time, because I said low, it's off. Okay. Kind of cool. Now, I have a challenge here. What if I want to add another light? So what if I want to do something like a traffic light? Right? I have green, and then I have another one. Let's see. Stop my simulation, right? Red, and also a yellow. Okay. And what if I, maybe I should turn these so they all kind of match. So I'm kind of going to get started here. I'm just going to delete some of this stuff. Okay. So I'm going to have 3 lights. And I'm going to give you a challenge, but you can copy mine if you would like. You're going to need 3 lights. You're going to need 3 resistors. Let's just make them all the same. All right, 470 ohm. Okay. You have 3 lights, 3 resistors. How do we connect everything together? Okay. And then also, what code do we need here in order to turn them all on? So the goal is we have the 3 lights connected, okay? And then also, when we have to write our code so that when we press start simulation, all 3 of them turn on. Okay, so it's a little bit of a stretch, but I think it's something worth trying. Another hint is that maybe it's a little bit crazy to do all three at once, so maybe you might want to put, you know, a set on the side and just try to do it with 2 lights. Okay, and the key thing here, and the thing I want to challenge you with, is that in engineering, one of the helpful tools is to look for patterns. Okay, so you see how this works, right? We have, for setup, if you have a nerve, if you're using a nerve, we've got to put the nerve number here and say output. That's to set it up. And to turn it on, you put the nerve number, and then, well, low is off, right? To turn it on is high. So that's a pattern there. So if you, hint, hint, if you use another nerve number, you would just have to have change the nerve number here. Another hint, right now I only have 1 line of code here. I could also put a second line of code here, or a third line, or however many number of lines. Okay, so I'm not going to finish it because I want to challenge you to kind of play with it. If you have questions, you can always reach out. All right, that's it for now. Enjoy, have fun exploding lights through the simulator, not in real life, and also getting them to work, and also enjoy coding. All right, take it easy.